Earthquakes are one of the most powerful natural forces on Earth, capable of reshaping the land in a matter of seconds. They happen when energy that has been building up underground is suddenly released, sending shockwaves through the Earth's crust. This energy release is caused by the movement of massive slabs of rock beneath the surface, known as tectonic plates. These plates are always shifting, though usually at a slow and steady pace. However, when they get stuck against each other, pressure builds up over time. Eventually, the stress becomes too great and the plates suddenly slip, releasing a huge amount of energy in the form of an earthquake. The place where this movement happens is called a fault line. Faults are cracks in the Earth's crust where plates meet and interact. Some faults slowly creep over time, while others remain locked in place for decades or even centuries before releasing built-up energy all at once. The exact location underground where an earthquake begins is called the focus, and the point directly above it on the surface is known as the epicenter. The closer a place is to the epicenter, the stronger the shaking tends to be. The strength of an earthquake is measured using the moment magnitude scale, which scientists use to calculate the total energy released. The shaking caused by an earthquake can vary widely from small tremors that go unnoticed to massive quakes that bring down buildings and reshape landscapes. Some earthquakes cause the ground to rupture visibly, splitting roads and shifting entire sections of land. Others occur deep beneath the surface, shaking the ground without leaving any visible cracks. Earthquakes can happen anywhere, but they are most common along plate boundaries, where tectonic plates meet and interact. One of the most active earthquake zones in the world is the Pacific Ring of Fire, a horseshoe-shaped region that stretches around the edges of the Pacific Ocean. This area is home to some of the most powerful earthquakes ever recorded, as well as frequent volcanic eruptions. Other regions like the Himalayas experience earthquakes due to the ongoing collision of large continental plates. Even though earthquakes can be sudden and unpredictable, scientists have been studying them for decades to better understand their causes and effects. By monitoring fault lines and measuring ground movements, researchers can identify high-risk areas and improve earthquake preparedness. While it is not yet possible to predict exactly when an earthquake will occur, understanding how they happen is a crucial step in reducing their impact. When an earthquake occurs, the energy release travels through the ground in the form of seismic waves. These waves move outward from the focus, shaking the Earth's surface and structures above. There are different types of seismic waves, each affecting the ground in unique ways. The first waves to be detected are called primary waves, or P waves. These waves travel the fastest and move in a push-pull motion, similar to how sound waves move through air. Because they are the first to arrive, P waves are often used in early warning systems to provide a few seconds of advance notice before stronger shaking begins. Following closely behind are secondary waves, or S waves, which move more slowly but cause much more damage. Unlike P waves, which travel in a straight line, S waves move in a side-to-side motion, shaking the ground horizontally and making buildings sway. In addition to P waves and S waves, surface waves are another major factor in the death or destruction caused by earthquakes. These waves travel along the Earth's surface rather than through its interior, and they move in a rolling or rippling motion. Surface waves are responsible for the most intense shaking and can cause the ground to crack, buildings to collapse, and landslides to occur. Because they travel more slowly than P waves and S waves, the shaking from surface waves can last longer, especially in large earthquakes. The extent of destruction caused by an earthquake depends on several factors, including the magnitude of the quake, the depth at which it occurs, and the type of ground beneath the affected area. Earthquakes that occur at shallow depths tend to cause the most damage, as the seismic waves have a less distance to travel before reaching the surface. Soft, loose soil can also amplify shaking, making structures more vulnerable to collapse, while solid rock can help absorb some of the energy. In urban areas, the effects of an earthquake can be devastating. Buildings, bridges, and roads are at risk of severe damage, especially if they were not designed to withstand strong shaking. Infrastructure failures, such as broken gas lines and electrical outages, can lead to fires and further destruction. In some cases, entire city blocks have been reduced to rubble within moments of a major earthquake. In addition to structural damage, earthquakes can also trigger natural disasters, like landslides and ground liquefaction, where soil temporarily behaves like a liquid, causing buildings and roads to sink. As scientists continue to study seismic activity, engineers and city planners use this knowledge to design buildings that are more resistant to earthquake damage Seismic-resistant structures are built with flexible materials and special reinforcements that allow them to sway with the shaking, rather than collapse under the stress. Advances in early warning systems and emergency preparedness have also helped to reduce the risks associated with earthquakes, providing people with critical seconds to take cover before strong shaking begins. While seismic waves are responsible for the immediate shaking of an earthquake, their impact extends far beyond the initial tremors. One of the most dangerous secondary effects of earthquakes is the sudden displacement of land and water, leading to events like tsunamis and ground ruptures. Tsunamis occur when an earthquake shifts the ocean floor, displacing massive amounts of water. Unlike regular waves caused by wind, tsunamis move rapidly across the ocean as a series of powerful surges. When they reach shallow coastal waters, their speed decreases, but their height increases dramatically, often resulting in catastrophic flooding. Coastal regions near earthquake-prone zones, such as Japan and Indonesia, are particularly vulnerable to these deadly waves. Ground ruptures happen when the Earth's surface cracks or shifts due to the intense force of an earthquake. These ruptures can tear apart roads, railways, and pipelines, making transportation and emergency response efforts difficult. In some cases, entire sections of land have been lifted or dropped by several feet, permanently altering the landscape. Large fault lines such as the San Andreas Fault in California are known for producing significant ground displacement during major earthquakes. Another dangerous effect of earthquakes is soil liquefaction. This occurs when saturated soil loses its strength and behaves like a liquid due to intense shaking. Buildings and other structures on this unstable ground can tilt, sink, or collapse entirely. This phenomenon is especially common in areas with loose, water-saturated soil, such as river valleys and coastal regions. Liquefaction played a major role in the destruction seen during past earthquakes in places like New Zealand and Turkey. Landslides are also a serious risk in mountainous or hilly regions affected by earthquakes. When the ground shakes, loose rock and soil can break free, sending debris rushing downhill. These landslides can bury entire villages, block roads, and create long-term hazards by reshaping the terrain. Heavy rainfall following an earthquake can further destabilize slopes, increasing the risk of additional slides. The long-term effects of earthquakes extend beyond physical destruction. In the aftermath of a major quake, communities often face food and water shortages, power outages, and displacement of large populations. Rebuilding efforts can take years, and economic losses from infrastructure damage and business disruptions can be enormous. In some cases, earthquakes have permanently changed the way cities are built, leading to stricter building codes and improved disaster preparedness measures. Despite the destruction they cause, earthquakes have also played a crucial role in shaping the Earth's surface over millions of years. They contribute to the formation of mountains, valleys, and other geological features, constantly reshaping the planet. Scientists continue to study earthquakes in hopes of improving early warning systems and minimizing the loss of life in future events. As scientists continue to study earthquakes, advancements in technology have helped improve our ability to detect and respond to them. While earthquakes cannot yet be predicted with absolute certainty, early warning systems have been developed to provide crucial seconds of notice before strong shaking begins. These systems work by detecting the initial seismic waves that travel faster than the damaging ones, sending alerts to people and infrastructure so they can take cover or shut down critical operations. Countries like Japan and Mexico have some of the most advanced early warning networks, helping to reduce casualties and damage when major earthquakes strike. In addition to early warnings, earthquake-resistant construction has become an essential part of protecting people and buildings in high-risk areas. Engineers design structures with flexible foundations, reinforced materials, and shock-absorbing systems that allow buildings to withstand intense shaking. Some skyscrapers are built with counterweights or base isolators, which help reduce movement during an earthquake. Retrofitting older buildings with modern reinforcements is also an important strategy in minimizing destruction. Countries like Chile and Japan have some of the strictest earthquake-resistant building codes in the world due to their frequent seismic activity. Beyond engineering solutions, emergency preparedness plays a key role in reducing the impact of earthquakes. Governments and communities in earthquake-prone regions conduct regular drills to teach people how to respond when the ground begins to shake. Families are encouraged to have emergency kits with food, water, medical supplies, and communication tools in case of disruptions. Knowing how to drop, cover, and hold on during an earthquake can significantly increase survival chances, especially in densely populated areas. Although earthquakes can be devastating, they also serve as a reminder of the powerful forces constantly shaping our planet. Over millions of years, earthquakes have played a role in forming landscapes, creating mountain ranges, and even influencing climate patterns by altering ocean currents and atmospheric conditions. Scientists study past earthquakes to understand how they have shaped the world and use that knowledge to improve preparedness for future events. The study of earthquakes continues to evolve as researchers develop better monitoring systems, improved building techniques, and more effective disaster response strategies. While we may never be able to prevent earthquakes from happening, ongoing scientific advancements help us minimize their impact and protect lives. Understanding these natural events not only helps communities stay safer, but also deepens our knowledge of the ever-changing earth beneath our feet.